Hi, and welcome to your science class. We are going to continue with the chapter Light, Reflection, and Refraction. And today we are going to learn how to draw the ray diagrams for the image formation by spherical mirrors, both concave and convex mirrors. Let's start drawing the ray diagram. My diagram is partially drawn. First, you need a straight line. So, with the help of a scale, draw a straight line of any length. Then mark the point C, and from C another 2 centimeter. Okay, let this be 2 centimeter. That will be F, and another 2 centimeter you will have the point P, that is the pole. This is the principal focus, and this is the center of curvature, which we have already done before. So a straight line of any length, point C, and from C 2 centimeter F, and from F 2 centimeter. At 2 centimeter you have P, but no need to mention that 2 centimeter. And then keep your compass at C and take the measure CP and draw the arc to get the mirror, that is the spherical mirror. This is a concave mirror. Okay, and then you can shade the back side of the mirror. So this is the reflecting surface. Mark M and N, the end points. Now take another 2 centimeter beyond this C. Take another 2 centimeter and draw one perpendicular AB. Put an arrow here. So this will be your object. Okay, and the object is placed beyond C, that is 2 centimeter beyond C. Now please understand, this is the object, and to get the image of this object we have to draw at least 2 rays. Now there are actually 3 rays. One is a ray of light which is parallel to principal axis. After reflection it will pass through F. Another one, a ray of light passing through C, center of curvature, will be reflected back in the same direction. And the third one, a ray of light passing through F. After reflection it will travel parallel to principal axis. That is something opposite to the first one. First one, a ray of light parallel to principal axis. After reflection it will pass through F. And opposite, a ray of light passing through F. After reflection it will travel parallel to principal axis. So out of these 3 we need to draw any 2 of the rays. This is your first ray, a ray of light which is parallel to principal axis. After reflection it will pass through principal focus. And this is your second ray, a ray of light passing through F. After reflection it will travel parallel to principal axis. And both these rays meet at this point, which is between C and F. So this was your object, and where the rays meet you will have the image of that object. So if you draw a perpendicular with the help of a scale, okay, now we see that it started from here. So this is the image of this point, that will be here. So this is A. So let's write this as A bar, and this was B. So this will be B bar, and let's put the arrow mark also. So this is the image. So you see, when the object is kept beyond C, the image is formed between C and F, and the size of the image is small, it is diminished. See this size, this is smaller, so it is diminished, and you can see it is inverted, it is upside down. A B, this is B A, B bar A bar, it is upside down. And we know that in a mirror, if the image is formed on the same side it is called real image. If the image is formed behind the mirror it is called virtual, and real images are always inverted. So the nature of this image is it's real and inverted. What is the size? It is diminished. Now this figure is already there in the textbook, and you have a related table of that for those diagrams. Now let's compare. Now where is the object kept? The object is kept beyond C. Now let's see this table. Position of the object is beyond C. Yes, beyond C. Now position of the image. Where is the image formed? Image is formed between F and C. Yes, correct. Between F and C the image is formed. Okay. Now third column is size of the image. What is the size of the image? It is diminished. Yes, it is diminished. See the size here. This is smaller, so it is diminished. And the last column is nature of the image is real and inverted. Yes, because it's formed on the same side, it is real and it is inverted. This is how you relate the diagram and this table. So you see here there are 6 positions at infinity, beyond C, at C, between C and F, at F, and between P and F. Okay, there are 6 positions given. So you have 6 diagrams also. Now what we have drawn is this one, beyond C. The image is formed between F and C. Okay, so there are 6 positions for the object for a concave mirror. Now as I told you all, there are 3 rays, but actually 4 rays which you can draw, but to get the image you need only 2 rays. Okay, so we have taken this parallel to principal axis after reflection pass through F, the other one opposite passing through F, after reflection it will travel parallel. Now suppose if we had taken the another ray, that is a ray of light passing through the center of curvature, it is reflected back in the same direction, it will pass through C again. So let's draw that and see where it is meeting. Now that is this a ray of light passing through center of curvature, it is reflected back in the same direction. Okay, so you can see that also meets here only. So any 2 rays are required, not 3. Any 2 are enough to get the image of the object. Now let's see the second position. Now we have done beyond C. Now the position of the object is at C. Now we have drawn another figure. So you can refer this figure. You have to take 2 centimeter, another 2 centimeter, and then you, keeping the compass at C, you draw the arc, get the mirror, mark M and N, mark the pole F and C. Okay, and now the object is kept at C. This is the object A, B. The object is kept at C. Now one, a ray of light parallel to principal axis, after reflection it will pass through F, that is this one. Second one, a ray of light passing through F, after reflection it will travel parallel to principal axis, and they both meet here at C only. So the image is formed at C, and see the size is almost the same, only thing this is inverted. So let's see the table. When the object is at C, the position of the image is also C. Yes, it's at C. Now size of the image is same size, okay, same as the object. The size of the image is same as that of the object. And the fourth column, nature of the image, it is real and inverted because the image is formed on the same side of the mirror and not behind it. It's called as a real image, and real images are always inverted. Now let's see the fourth one, that is when the position of the object is between C and F. So this is the figure. The object is kept between C and F. Okay, so the same diagram, 2 centimeter here, pole, center of curvature. So the object is between C and F. Now when the object is between C and F, you can take the object always as either 2 centimeter or 1.5 centimeter. Okay, so here a ray of light parallel to principal axis, after reflection it will pass through F, that is this one. Another one, a ray of light passing through the center of curvature. Okay, passing through the center of curvature after reflection will come through center of curvature only, and they both meet here. Otherwise, you can also take a ray of light passing through principal focus, that is this way. After reflection, it will travel parallel to principal axis. That will also meet here. But here in the textbook, they have taken the ray of light passing through the center of curvature. So let's see the table. The object was kept between C and F. Between C and F, this is the object AB. Where is the image formed? The image is formed beyond C. Image is formed here, B bar, A bar. Size of the image, you can see this is the object and this is the image. The size of the image is enlarged. So size of the image is enlarged, and again it's on the same side of the mirror, so it is real, and real images are inverted. So real and inverted. I'll skip the fifth one at F and I'll go to the sixth one when the object is kept between P and F. This is your pole and this is your F. The object is kept between P and F. Now here you have a ray of light passing through center of curvature. After reflection, it will travel parallel to, it will travel in the same direction. And there is another ray of light which is shown in the textbook in this diagram, that is this one, a ray of light which is going to P. So whatever the angle of incidence, that will be the angle of refraction. This is the next one. Now for this you normally need a protector, so that's why we don't take this. Now let's draw this without using this line. We will take another ray of light, either parallel to principal axis or passing through F. Here we have an object between F and P. This is the object AB. This is 1.5 centimeter, and the first ray is a ray of light passing through C. Okay, if it is passing through C, it will be reflected in the same direction without any deviation. So that is this one. Now the other one could be a ray of light passing through F, but F is this side, so we can't draw that. We don't need that one because F is this side. If it is passing through F, it will not get reflected by the mirror, so we will skip that one. We will take a ray of light parallel to principal axis, which will travel through F after reflection. So I have taken a ray of light parallel to principal axis, and after reflection it will travel through F. But here you see that these lines are not going to meet. Okay, because they are diverging, they will never meet this side. So what we can do is we can extend it on the other side. So I have extended it behind the mirror, both these lines, and they meet at this point. So where they meet, the image will be formed. But you can see I have used here dotted lines for the image as well as for this light, because a ray of light cannot travel through this because it's opaque, it's a mirror. And this is not a real mirror, a real image, it is virtual because it's behind the mirror. That's why I've used dotted lines. So you see the image is formed behind the mirror. Now let's refer the table. Now your table says if the object is kept between P and F, between P and F, this is the object, then where is the position of the image? Behind the mirror. The image is formed behind the mirror. Now what is the size? You can see it is enlarged. It is enlarged. And the nature of the image. Now since the image is formed behind the mirror, it is a virtual image, and virtual images are erect. See, it is upright, it's not inverted. So nature of the image, virtual and erect. Now for all the 5 positions of the object other than the first one, we were taking the size of the object as 1.5 centimeter to 2 centimeter and above the principal axis. Okay, but only when the object is at infinity, we can take that as 3 or 4 centimeter, and it's not only above but below the principal axis. It's something like this, A, B. When it is at infinity, you can see some dotted lines here. So it is not just beyond C, it's far away, it's at infinity. That's why this dotted lines. And two rays of light parallel to principal axis, one up, one down. After reflection, they will meet at F. Okay, so that's in the first one, first column, the table. At infinity, position of the object, position of the image at the focus, and highly diminished point size, because they both meet here. So it is point sized. And the nature, because it's on the same side, it is real, and though small, it is inverted. So I have drawn only two figures, the others I just explained. So I would request you all to draw all the 6 positions. Now those diagrams were for the concave mirror. Now this is for convex mirror, and only 2 positions. This you don't have to draw this, but you have to just understand the position of the image, the object, the size, and the nature. So this is your convex mirror. Your principal focus and the center of curvature is on the other side, on the right hand side. So the first position is at infinity. The object is kept at infinity. So the rays of light traveling parallel to principal axis, after reflection, it appears to come from principal focus. So dotted lines here. Okay, so the image will be formed at F. So position of the image at the focus behind the mirror. Now what is the size? Point sized, highly diminished, point sized. Now since the image is formed on the other side of the mirror, it is called real or virtual? It's on the other side of the mirror. Yes, on the other side is virtual, not real, because the rays of light cannot pass through the mirror. So the nature of the image, virtual and erect. So virtual images are always erect. Please remember that virtual images of a mirror are always erect, and the real images are inverted. Now let's see the second position, between infinity and the pole of the mirror. So between infinity and the pole of the mirror, this was at infinity. So this is little closer to the pole, and this side we don't have the center of curvature or the principal focus, it's on the other side. So first a ray of light parallel to principal axis, after reflection it appears to come from F, and the other one passing through the center of curvature. It will be reflected back in the same direction, so we need to extend them. They both meet at this point, that is between the pole and F. So position of the image is between P and F, behind the mirror. See the size, this is bigger, this is smaller. So diminished and virtual and erect. So from this you understand that a convex mirror always gives virtual and erect image, whereas a concave mirror, the image could be real and inverted, but see this last one, it is virtual and erect. Now here we have an answer for our question that why the dentist use a concave mirror, and even for shaving we use concave mirror. Why? Because if our tooth lies between the principal focus and the pole of that concave mirror, you get an enlarged image which is virtual and erect. All the other images form, the nature of the image is real and inverted for a concave mirror. Okay, but only when the object is between the pole and the principal focus, or we can say within the focal length, then we get an enlarged image which is virtual and erect. So the same reason that for shaving also we use a concave mirror, and in that also our face should be within the focal length, that is between P and F. then only you get an enlarged virtual and erect view of the image, and that becomes that makes our sieving easier.